or we've been told that the skateboarder skates until he jumps off the ramp, okay, shoots off the ramp at an angle of 58 degrees above the horizontal, okay, and we are told that the speed, the velocity is 6.6 meters per second as the skateboarder shoots off the ramp, okay, and we are told also that the ramp is 1.2 meters above the ground. So for A, we are required to calculate the maximum height, which is from there to there, okay. For B, we are required to calculate the distance from the edge of the ramp, okay. This is B, the distance. So we know for us to find the H max, it will be that plus that. Then we can get the maximum height. So first we must resolve the velocity into components Vx and Vy. Okay. Assuming upwards is positive, taking up as positive and right as positive, we take note of our acceleration due to gravity. It's negative 9.8. Okay. So the G is negative because of taking up as positive. But if we take down as positive, our acceleration here is going to be positive. So in this case, we took up as positive, therefore G is negative. So let's resolve our velocity Vx into Vy. So we know Vx is equals to 6.6 cos 58. And the velocity in the y is equals to 6.6 sine 58. Okay. So what do we know? We know that when to calculate this change in y from there to there only, it had an initial velocity in the y, which is this one. Okay. Initial velocity in the y is equals to 6.6, which was the initial speed, sine 58 degrees, which was the angle from the horizontal, plus G multiplied by time. Our G here, we said it's negative because we are taking up as positive. Okay, so gravity will always be pushing a moment, pushing it down, the acceleration due to gravity. That's why when it reaches terminal velocity of 0 here, which will be your final velocity, is 0 when it reaches terminal velocity. But that terminal velocity is going to be reached after how long? From initial to there. That is what we want to look for, t. After how long are we going to reach the terminal velocity, which is t? So the t is equals to 6.6 sine 58 degrees over 9.8. Okay, we just make t subject of the formula, push everything to the left, divide by 9.8, okay, then we get 0.57 seconds. So that is our time. Okay, so now we want to calculate the change in y. Okay, the distance moved from here to there until it reached terminal velocity. We know that Vy, final velocity in the y, which is this one, final velocity in the y, when it reached this point, from here initial to reach this point, that was the final or the terminal velocity when Vf is equals to 0. So it was 0, so it will be 0 squared, we just get 0. V initially, it's 6.6 sine 58, you square it, plus 2 multiplied by the gravity, which is 9, but the sign is negative, multiplied by change in y. So we make change in y subject of the formula. Just we push this to the negative, it becomes negative. Times negative, times negative. We divide both sides by 2 times 9.8, we are left with change in y. So our change in y there, so our answer there is equals to 1.5983 something meters. Rounding it off, we are going to get 1.6 meters. So that is our change in y. Change in y from there to there. Okay. So we want to calculate the maximum height above ground. This is our ground. So the maximum height above ground when it reaches that point, it's going to be 1.2, which is the height of the ramp, edge of the ramp above ground, plus this height which was reached from the initial shootout. So it's going to be h max is equals to 1.2 plus 1.6 meters, which is equals to 2.8 meters. Okay, so for now we are going to calculate this distance from the edge. What is this distance? And we know the time taken for it to move from there to there. Okay, and now it will be with respect to x.